Now, good morning to all. Now, in today's lecture, I am going to cover the topic spherical refracting surface, refraction at convex surface, refraction at concave surface. Now, let us understand that what is spherical refracting surface. Now, spherical refracting surface is a part of a sphere of refracting material. A refracting surface which is convex towards the rear medium is called convex surface, and which is concave towards the rear medium is called the concave surface. So here it is convex towards the rear medium, so it is convex surface. It is concave towards the rear medium, so it is a concave surface. Now, assumptions. Object is the point object lying on the principal axis. The incident ray and the refracted rays make small angles with the principal axis. The aperture or the diameter of the curvature or the curved surface is small. These are the assumptions. And the Cartesian sign convention. Incident ray is taken from left to right. All the distances are measured from the pole of the refractive surface. The distance measured along the direction of the incident ray are taken positive and against the incident ray are taken negative. The vertical distances measured from the principal axis in the upward direction are taken positive and downward direction are taken negative. Now let us discuss the refraction at convex surface. Now understand it very carefully. If one diagram is clear to you, then you will be able to follow the other diagrams in the other slide very easily. Now here I am discussing the rear medium to the denser medium, and the image is real. So let us see that this is the point object, the incident ray. Now we know that the line joining the center to the point of incidence is perpendicular to the surface, so the refracted ray will bend towards the normal and the image will form at point I. Let alpha is the angle between the incident ray and the principal axis, beta is the angle between the refracted ray and the principal axis, gamma is the angle between the radius of curvature and this you can say the CA and the principal axis. Now in each and every diagram you will put the values of alpha, beta, gamma in the same manner, that is alpha with the incident ray, beta is for the refracted ray, and gamma for the line joining the center of curvature and the point of incident. Now look carefully in the triangle AOC. Again in AOC, now A is the straight line, so this is the angle of incidence I. Alpha and gamma, they are the interior angles. From the exterior angle theorem, the exterior angle is always equal to sum of the interior opposite angles. So we can say that I is equal to alpha plus gamma, which is written over here. I is equal to alpha plus gamma. Similarly, in triangle ACI, the exterior angle is gamma, so gamma is equal to R plus beta, or R is equal to gamma minus beta. If once you have made these equation I and R in terms of alpha, beta, gamma very correctly, then the 80% work is done. So make these equations very carefully. Now tangent alpha in this diagram. Tangent alpha is perpendicular, that is AM upon O. m, or alpha, since angle are very small, so tan alpha can be taken equal to alpha, so we can say that alpha is equal to ma upon mo, और also since m is very near to p, curvature को हमें small लेना है, so we can say that mo is equal to op, so this can also be written as ma upon op. Similarly tangent beta ma upon mi, beta ma upon mi or ma upon pi, gamma ma upon mc or ma upon pc. So these are the equations. Now according to Snell's law, sin I upon sin r is equal to mu2 upon mu1, or I upon r is equal to mu2 upon mu1, or mu2 I1 is equal to mu2 I. Now put all the values from I, r and alpha, beta, gamma in this equation. So this equation will reduce to this one, that is mu1 upon po plus mu2 upon pi is equal to mu2 minus mu1 upon pc. Now look at the figure. po is equal to minus u. According to the sign convention, the distance opposite to the incident ray are taken negative, so po is equal to minus u. U is for the object. pi in the same direction of the incident ray, and it is the position of image, so pi is equal to plus v, and pc is radius of curvature, which is again in the same direction, so pc is equal to plus r. All the distances are measured from the pole. Now when we put the values, then result reduces to mu1 upon minus u plus mu2 upon v plus mu2 minus mu1 upon r. So look at this, mu1 upon minus u. Object is in the medium whose refractive index is mu1, so mu1 upon u. The image is in the denser medium mu2, so this is mu2 upon v, and mu2 minus mu1, because in the lens formula you remember that 1 upon me minus 1 upon u is equal to 1 upon f, means v minus u, 1 upon v minus u. As I feel that it is very easy to remember that 1 upon v minus 1 upon u. So here again just look carefully, v term mu2 upon v, mu2 कौन सा है जिसमें की इमेज बन रही है v, तो उसी का रिफ्रैक्टिव इंडेक्स mu2 upon v. ऑब्जेक्ट mu1 में है तो mu1 upon v u, एंड सिंस v माइनस u, तो वही पहले ही हमने यहाँ पे u की टर्म लिख ली है, तो mu1 upon minus u plus mu2 upon v, and image minus object, that is mu2 minus mu1 upon r. So in this way, if you just keep it in your mind, then this formula cannot be written wrongly. Now refraction, on the basis of this, refraction at convex surface, lekin here the image is virtual. The only difference is of the ray diagram. The final result is same. So you have to draw the diagram very carefully. Here the object is O, incident ray. Now since the ray of light is traveling from rare to denser medium, and the final image is the virtual image. Virtual image means the image is on the same side. So ray diagram will be like this. Here angle I is more, angle R is less, so final image is forming at this position. When we follow the same procedure as done in the previous slide, you will get again the same result, that is mu1 upon minus u plus mu2 upon v is equal to mu2 minus mu1 upon r. Similarly, the refraction at concave surface for the virtual image. The difference is only in the diagram. The result will be same. As you remember that 1 upon v minus 1 upon u is equal to 1 upon r. Lens formula is same for concave lens as well as for the convex lens. Similarly, in all the situations only the ray diagram will be different, but the final result will be same. So here you have to keep it in mind what, that these equations are written correctly. These equations will be different in each and every position, but these equations will be different as well as these values will be different, but when you substitute them and simplify, you will get the same result. So for drawing the ray diagram, you have to keep in mind that whenever the light travels from rare medium to denser medium, it bends towards the normal. The line joining the center of curvature to the incident point of incidence is always normal to the surface. So उसको normal लेते हुए line ray of incident ray and refracted ray, if you draw properly, then you will get the proper result without any mistake. Similarly, the refraction from denser to rare medium. अभी तक हमने किया था rare to denser medium. These two diagrams are for the denser to rare medium. Here there is a little bit difference. Look carefully. Here the object is in the denser medium, that is in mu2, and the image is in the rare medium, that is mu1. So again the result here, the changes will be mu2 upon minus u, means the object u के ऊपर वही refractive index आएगा जिस medium में object है. So this will be mu2 upon u, and here mu1 upon v, and then again image minus object, so mu1 minus mu2 upon r. This is the easy way to remember. So minus mu2 upon u plus mu1 upon v is equal to mu1 minus mu2 upon r. Similarly, from denser to rare medium for virtual image, the result will be same. From concave surface virtual image, the result will be same. Now note that expression for object in rare medium. When the object is in the rare medium, then equation will be mu1 upon minus u plus mu2 upon v is equal to mu2 minus mu1 upon r. When object is in the denser medium, then mu2 upon minus u plus mu1 upon v is equal to mu1 minus mu2 upon r. However, the values of u, v, r, etc. must be taken with the proper sign convention while solving the numerical problems. The refractive indices mu1 and mu2 get interchanged in the expression. So that is all for today. Thank you and have a nice day.